I'm delighted to welcome Jeff Wallace this evening. Many of us know Jeff. We might have heard Jeff before. He's a well-known enthusiast and expert. It's the next talk which we've deliberately arranged to talk about Western Harbour, because it's an area where there is going to be change in the next few years. We don't know what change yet. Some of you will have been at our first talk. It was as long ago as September 2019, before any of us have heard of coronavirus, when we had the talk about the tobacco bonds at the actual B bond. We then moved on 2 weeks ago to talk about underfloor yard, and this evening Jeff is going to fill in all the other heritage in the Western Harbour. I'm not going to introduce what you're going to talk about, Jeff. I'm not going to introduce you, because I know you've got a slide showing exactly who you are. So I'm going to pass over to Jeff. Jeff tells me he's quite hard to stop talking, and I was saying I don't know how to stop somebody on Zoom. I'm not even sure I can mute him. So I can phone you up, Jeff. Okay, I might phone you up. But maybe 55 minutes to an hour. But I can guarantee it's going to be absolutely fascinating and instructive. So over to you, Jeff.
Thank you very much, Simon. Let me just start sharing the screen, if I may. Okay, hopefully you can see that. Yes, okay. Good evening, everybody. Thank you for joining us. And thank you for your introduction, Simon. Let me just introduce myself very briefly, if I may. I started off life as in the aircraft industry as an apprentice, but I started working as a volunteer there on the Crofton pumping station engines up in Wiltshire, near Marlborough. And frankly, it changed my life. I soon abandoned abandoned aircraft, I suppose, and joined a small company, which actually I ran for about 30 years, retired in 2008, became a consultant. And as you can see from the bottom half of my slide, retirement has proved somewhat elusive. I'm busier now than I was when I was running the company. So let me hasten on to explain the area we're going to be looking at tonight. This is the Bristol City Docks Conservation Area, and the area to the red is the one to the left is the one we're looking at. It's called Area 1. Most of the rest of this area, the conservation area, has now been developed, and so that's why the planning authorities and the mayor are starting to think about this area to the west end of the harbour. So it's the area where the former route of the river, now the floating harbour, joins the new cut, and at the same point, of course, the road, the main road going north-south across the city, has to join, has to cross at this area here as well. So it's a very interesting area where there's a lot of water, a lot of activity, and a lot of road traffic. So this is not only a difficult area to plan the future of, but also to make any changes. But nevertheless, it has quite a lot of history in it. A lot of heritage survives. And whilst you might not think it's very interesting initially, I hope within the next hour you're going to change your mind. Let's go back to the 1860s, where you can see to the left here, Jessop's Lock. There's the junction lock there is also Jessop's Lock. That one survives, this one doesn't. But an improvement was made in the 1840s here by Brunel, who constructed this lock. And across it, he put a bridge, a swiveling bridge, and there was another bridge swiveling across Jessop's original lock. That's a rather wonderful photograph, that, isn't it? But you can imagine that if a ship of any decent size is coming out through here, it's got to turn very sharp to the right, or it's going to hit this bank. It's actually not very well aligned with the river. And so in the 1870s, the engineer of Bristol City at the time, Howard, created a lock that is much longer and wider, but is also it's pointing down the river, as you can see. This is Brunel's original lock. This is where Howard's lock, Jessop's lock was. That's been closed off now, and you can see the swivel bridge here over Brunel's lock, and another swivel bridge here. So again, you can see here Jessop's South Lock. That's now closed off here, although there is a sluice in it to allow water to flow through. This is the 1873 junction lock with the bridge over it, a swivelling bridge here which survives. Brunel's Lock has been closed off here, and there's a dam there as well. This is, sorry, this bridge here was originally here. So this is Brunel's swivel bridge that was over his lock, has now been moved to the lock that Howard built in 1873. And a replica of that bridge was built here. So this is called the replica bridge. Incidentally, notice the warehouses here with their sawtooth roofs. Those roofs have changed now. This is Tobacco Bond Warehouse A, grade 2 listed from 1902, built by Cowlins. And this is B, 1908, similarly listed. And this is important because it's the first major building in Britain to use Edmond Coignier's reinforced concrete. So it's brick clad, but the structure inside is reinforced concrete, again built by William Cowlins. And similar construction about 10 years later, also built by Cowlin, is C Warehouse. This is the self-storage place at the moment. Of course, there were two more later bonded warehouses that have now gone. I'm assuming that everyone knows what a bonded warehouse is. If not, forgive me if you do. It's where tobacco came from the ship and was held in bond. So a bale was taken out each day to go to the factory. And at that point, when it came out of bond, the tax became payable on it. So that's why these are very strong and secure structures. So we're looking at the junction lock now, Jessop's junction lock, grade 2 listed, 1804 to 9. And you can see these recesses in the walls where the gates would have retreated into, and there's another pair of recesses there. Just to the left of this photograph, you're probably familiar with these rather wonderful dock workers' cottages from 1831 in rather good condition. And of course, the Junction Lock Bridge from the 1870s. This is not listed. In fact, none of the operational structures are listed. And if you go and have a look at this, and just on the side, you'll see this rather wonderful cast iron plaque. Again, William Cowlin's name on it as the builders, but Lysarts made it. They had a factory just to the south side of the feeder canal. Nothing left of it there now except a slight recess on the side of the canal, which is where an arm of the feeder canal went in to feed the works. But this is a very famous and well-established Bristol manufacturer of steelwork. A rather sad survival, this, I'm afraid. The Ashton Avenue swing bridge, built by Bristol City and the Great Western Railway, again by Lysarts, designed by John English. And this was operated by Armstrong Whitworth's hydraulic machinery, of which more later. So it sits on a pedestal there, which has a series of rollers, and there's a weight at this end, and the whole thing swings around that center. Now, this was the original appearance, absolutely beautiful. Look, there's a walkway along here, a gantry over the top, and a cabin, a control cabin, where there would have been very good view of the railway and, of course, of the new cut. A shame that none of that survives now, but that was a rather wonderful looking bridge originally. Now, Thomas Ware's, a very interesting manufacturer or processor of leather. They're tanners, and they were established in 1840. They're the largest traditional pit tanners of leather in the UK, and they're selling worldwide now. These are the sort of things that they make leather for. They don't actually make these products, but they make leather to supply those who do make them. If you're interested in this, just go and have a look at Thomas Ware's site, thomasware.co.uk. There's a video there of the process, and I'm just going to illustrate it briefly. As you approach Thomas Ware's from Coronation Road, you'll know that There's an office just inside. That is a listed building, but the rest of what you're going to see is not listed. So there's a drying house, for example, here, which is not listed. If you go in, and I'd advise you not to do this at night, you'll find that there's a rather wonderful array of lime pits initially. This loosens the hair and the grease, and it's then scoured off by these machines and by manual processes. You can see on the table here, there's a caliper that is used to check the gauge or the thickness of the leather. And these are used to just pull the leather about. You whack that into the leather and pull, and the leather slides about. You see the chemicals here. It's all very traditional and still works very much as it did in the Victorian times. And then it goes on for tanning. It's in these pits for a year and a day. Oak bark tanning, held on these frames here. And these things are mechanical stirrers. This just rocks back and forth and stirs the tea, as it were. And this is the product going in or out. Andrew Brearley, the managing director here, very kindly showed a group of us from the Bristol Industrial Archaeology Society round about 3 years ago, and it was absolutely fascinating. These are rotary washers, and these drying lofts, that was the building I showed you the outside of. I don't think this is used nowadays, but it's not listed, and it's quite worrying because this is a very traditional drying loft. Can you see the hooks all along here to hold the hides up in the draft? And there's another drying shed as well there. I think there are two. All sorts of traditional machinery, historic machinery. As a mechanical engineer, of course, I find all this absolutely fascinating for finishing and rolling here. This is a wheeling machine made in Bootle and still in use. Slightly more modern machines here. This is a process of colouring. There's a spray booth there. You'll notice a lot of the leather had a very high sheen and different colours on it. All done in this works here, where other finishing works are done. You can see there's a lot of work going on here. This is a very successful business, and it's entirely due to the managing director. Hope he doesn't mind me saying that. And then the final stage, one of the semi-finishing process is to stamp out shoe soles, as you can see here. These are all the different shapes that go under a pressing machine here. And so this has a sharp edge, which is pressed into the leather to make the soles of shoes and boots. High quality stuff. We're talking about, you know, hundreds of pounds for a pair of shoes, if not more. And deservedly, they had the Queen's Award for Enterprise in 2018. This is the final product, and this was our host. And thank you, and Alistair, if you're listening. Now, we've moved down a little bit further to the west, and this is the end of Brunel's Lock. We're looking westwards, and again, you can see recesses where the lock gate would have swung across here. So you need to imagine that 30 foot, that's about 9 meters of silt, doesn't exist. So we're looking into an elliptic shaped basin here, and there would have been a lock gate, a very substantial one, hanging on that peg. Can you see that hinge there? There's another one about 20 feet down, and the caisson gate, as it's called, would have hung on that, and when open, the paddle would have gone into those recesses there, and the whole gate fits into that enormous recess. It was so heavy that actually it was floated. It was called a caisson. It was partially full of air, partially filled with air, so that it was negative or slightly negative buoyancy. So it would actually open and close nicely. On the right, this is where we were looking previously. If you look to the right, there's a rather interesting step along the side of the lock, Brunel's Lock. This is relatively recent, and I don't know what it's for. I would love to know if somebody can tell me what it is. I think it may have had something to do with the wartime, maybe provisions during the war for using this lock again if the later Howard's Lock was bombed. But I'd very much appreciate if somebody could tell me what this recess was constructed for along the side of the north side of Brunel's Lock. Now, looking back up the lock towards the east, we're looking at the downstream side of the replica bridge over Brunel's Lock. This is 1927, and notice that recess I've just shown you is not there. There's a rather lovely curved wall, and notice the elliptical shape of the lock itself, beautifully made. Now there is a dam further up, like at the city end of the lock, but another one was being constructed or maybe refurbished in 1927, and this is still here. And you'll notice that there are 4 quite large underfall sluices there. This is about 30 feet up here. So this is quite a substantial construction, and it's still there. There we go. So we're looking at the left hand of those sluice gates now. Here is the sluice gate. It's now, or was, electrically operated, but about 10 years ago, I think, maybe a little more recently than that, this mechanism failed, and the money wasn't available in the council to put it right. And so it was abandoned, and I'm afraid that's now resulted in this silting up. So looking from the upstream side, where is, oh, I can't see it now. Yes, there it is. The sluice gate is just there, and you can see that the whole thing is filled up to just a few feet below the normal water level. This is during the scour. The water's been let out, and so you can see that it's full of mud. Just see the handrail there. This is the scour actually taking place. By that I mean every couple of weeks the sluice gates are opened in Junction Lock. The lock gates, we're looking downriver now, the lock gates in Howard's Lock, the new entrance lock, are opened, and the water is allowed to just flow through to wash out the silt. And you can see it's not very deep in Cumberland Basin, but we're looking here at Brunel's Lock, the intake of Brunel's Lock. There's a later walkway in front of us, you can see, and it's completely silted right up now, although I'm assured by the assistant dock engineer that if that sluice gate was opened, if I just go back, if that was refurbished and got working, this would very soon clear its own way through. The mud would gradually wash away. It would take some while, but it would just do it for free of charge, as it were. So let's now go further down and have a look at this bridge, which is over Brunel's Lock. And it's a replica of Brunel's Swivel Bridge, which we'll see in a minute. Again, this is grade 2 star listed. It's wrongly attributed to Brunel. There were actually 3 bridges of this design in Bristol, and it's all been very confusing for the historians. But this has now been established by David Greenfield, the historian engineer, to have been the replica of Brunel's Bridge, although this was, I believe, a swing bridge as well. So that's now static, of course, and is propped up on the dam that is built across Brunel's Lock. We've now gone across to the north to have a look at Howard's entrance lock, which again has these floating or semi-floating caisson gates. Again, not listed, this structure, but a very fine construction nevertheless. And these are the 1870s dock buildings at the entrance. Notice lots of mooring bollards, a whole series of those, which are rather wonderful, and some capstans, which of course are you can operate by putting a bar into there, or a whole series of bars, and have a series of men pushing this round. This is actually a newfangled bollard, which is powered by hydraulic pressure. If you take up that grill, that cast iron grating there, and have a look underneath, you'll find there's lots of rather interesting machinery. And this is actually a three-cylinder, 3-cylinder engine. There's the crankshaft driving that pinion, and that then drives the underside of this. So you admit water to these cylinders, and that came from under full yard. You heard about that, I think, at the last webinar from Andy Blaney. The pumps are still working down there. They provide, or they used to provide, 750 psi water to this end of the dock. And the mains are still there. They're cast iron mains. And it is possible to turn the valves on at under full yard. Last time that happened, there were rather exciting fountains in various places because the castings, I'm afraid, are no longer in particularly good condition. So the pipe is not serviceable, but this equipment is still complete. And there are several sets. I think there are 5 sets of these powered capstans together with their machinery just hidden underground. Talking of underground, if you have a look at these gratings, you'll find that there's an awful lot of them, and you can start to see that they have a purpose. Underneath, there are ducts which carry the hydraulic mains, and then there are things that, if you peer down underneath, you can see there's some more machinery, which is rather interesting. And this is a thing called a hydraulic jigger. And it probably would have been in there. I can't remember which one it was I photographed. I think it's not there now, but there are several of these still in existence. And they used to operate the lock gate. So there was a chain from the lock gate coming to this hydraulic jigger, as it's called. So what we're looking at there is a series of pulleys. One end of this chain would have been fixed, and then it goes round the pulley, back round another pulley, back round, and does that 3 times in this case, so that it multiplies the pull, the amount of chain that is pulled in. It reduces the actual force on that chain, but it increases the length that the chain is pulled. And this is the control mechanism here. And again, there are several sets of this still in existence, and it's all extremely interesting. You can just see the big hydraulic ram underneath, which pushes this lot. The hydraulic ram pushes this yoke and these pulleys, in this case to the right, so that the chain is drawn around this series of pulleys and operates a paddle for letting the water out of the locks, or operating the lock gates themselves. If you were flying over the Cumberland Basin in 1920, as somebody was here with a camera, and you looked down, you'd have seen this rather interesting iron grid called the grid iron. This is the Round Ferry. I think you can see where we are. This is Brunel's Lock. There's Howard's Lock. And you can see 4 timber constructions here. And this would have been used, as you see below here, for a ship to come in at high tide, rest over the grid iron, and then when the tide went out, it would lean against these 4 series of timbers here, and you could carry out careening work or minor repair. It looks rather as if this might be major repair. Look, there's a whole plank being renewed there, I think. So they would need to get that done before the next tide came in, or maybe they did it at very low tide, slack tides. And here, this is what it looks like now. The gridiron is almost certainly still there. I have seen it. Again, if this were washed out or allowed to clear by getting a flow of water through, the gridiron would come up again, and these would need to be restored if it was felt worth it. But this is a really interesting piece of historic maritime structure that ought really be visible. Let's move on now to Isambard Kingdom's Brunel's Swivel Bridge, which was constructed just a few years after the SS Great Britain in the same dockyard, actually. This dates back to 1849. It's Brunel's first movable bridge. It's the only one to survive, and it has quite a lot of interesting and innovative features that he introduced. As I go through this, you'll see these little clouds which illustrate these design features, these innovations. Um, the bridge has two side members, as you can see here, sitting on a very substantial wrought iron ring, and that itself sits on four wheels. So the whole thing pivots about this. There's nothing supporting this end. So at the other end, there has to be a considerable weight. This is a series of very large and heavy slabs of cast iron, and they're just supported a little bit by a track here, just to make sure that this stays in alignment. Now, can you see that these ribs or the transoms slope one way here, then they slope the other way, and then they change again? Now that's a clever arrangement to make this internally braced, self-bracing. It can't rack, as it's called, and if you can see me, but racking is that, or like that. So he's avoided having to put any cross bracing in by putting the ribs in at an angle. The downside of this is that these are fabricated from four angles and a plate, all riveted together, and they have to then be bent, or rather bent before they're riveted together, I suppose, and then bent the other way. So this is quite a complicated design. It's very strong. It doesn't actually save very much weight, because if you were to put simple diagonal struts in, they would do the job just as well. But he wanted this to be innovative, perfect, good engineering, and it is, but it must have been a pain to build. As I mentioned, it was constructed in the Great Western Dockyard by the same firm that constructed the SS Great Britain. I mentioned that it was relocated to its present position over Howard's Lock. When that happened, about 10 feet or 3 meters was taken off this end. It was decommissioned, of course, in the late 1960s when the Plimsoll Bridge was constructed, and then it was just abandoned after that. There was actually a plan to cut it up, but fortunately the dockmaster then, the dock engineer, David Neal, had a look at it and looked up, oh, it's listed, checked into the history, and started to realize this was actually historically very important, and cutting it up was not the best plan for it. But no further maintenance work was done, and it became derelict. It is actually now derelict, and the fear is that one day it's going to collapse. But we've taken some interest in it to try and avoid that happening. It's grade 2 star listed, and it's on Historic England's, or English Heritage now, Historic England's buildings at risk list. Now, here's another very important design feature. This is not the Brunel Swivel Bridge, but the other swing bridge that you saw at the beginning of my talk when it was being cut up. But it's the same shape. So it has a balloon at the top and a triangle at the bottom, forming a very, very strong side beam. But Brunel went one better than this. One of the problems with iron, this is made of wrought iron, which is not steel, it's something earlier than steel. It's a handmade form of very pure iron, and it's quite flexible. It's rather springy, and when it's something 70 foot long, it acts a bit like elastic. It bounces about rather. So Brunel put a couple of tie rods. Can you see on this cross-section drawing, and this is the original drawing from the record office, which is just next to the swivel bridge, incidentally. There are tie rods inside here. They went down inside this tube, which is bent, incidentally, so difficult to make, and the tie rods then have to be bent round as well. And these things were post-tensioned. What they did was to jack up the nose end, the free end of the swivel bridge, whack in some wedges to tighten up these tie rods, and then let it relax. And so now the tie rods are taking the weight. They're making it very stiff, and they're making it very strong when it's not across the entrance lock. In other words, the end that is not supported is trying to sag, but these tie rods are holding it up and making it very stiff. Now that's important, because if you imagine the bridge closing across the entrance lock, it's got to come onto an abutment on the far side. And if it's sagged, it won't, it will just run into it. So this is all very carefully thought through and a very good piece of design. Excuse me. I'm afraid after 50 years, this is the sort of thing, we call this in the trade transparent metal. It's very good for growing plants, but it's not great for supporting a bridge. What you're looking at here is a repair plate. So you can see they've put a repair plate over a hole, and the repair plate has gone as well. So this is quite ripe. So the first thing that we did, a volunteer group came together, sponsored by the Avon Industrial Buildings Trust and the Bristol Industrial Archaeology Society, the Clifton and Hotwells Improvement Society, and a number of others. Volunteers came out on their days off at the weekend and peered into everything, as you can see. Lots of photographs. Historic England very kindly gave us a grant, so we were able to do a lot of other investigations, including surveying the drains. This is a borehole investigation to see what the soil is like here, because just over here, we're looking to the west, of course. You may recall that here is Howard's Lock, and that ran straight across the site. I'm sorry, I meant Jessop's Lock, didn't I? That ran straight across the site. And so we suspected this might be fill. And sure enough, down to 10 meters where it hits sandstone, it is all fill. This is just settled alluvium. But the bridge itself is on very substantial timber bearers, and it seems to still be really quite stable. Minimal settlement. So we're quite pleased with that. We know what's going on underground. The drains, on the other hand, which are important to keep the undercroft here. There's a pan underneath here, about 18 inches deep, 400, 500 millimeters deep, which fills up with water in flood. So there have to be drains, and they're not working. Fortunately, we had one or two young helpers who could be got inside the small areas to help clean. A lot of debris and rust and stuff that you don't want to hear about inside these boxes. And so that was all cleared out. And as you can see here, we've started putting on 2-pack epoxy paint to just try and protect it a little bit. This will all have to come off again one day, but you can see more of our transparent metal here, as we call it. And this is in a primary structure. So we wanted to just keep that from rotting away. So we put a roof over it and called it the chicken shed, designed and erected by volunteers, and still there. Gets vandalized occasionally, I'm afraid. We've had kids doing wheelies on their bicycle on the roof here, which is quite exciting for them, not for us. Now, the whole bridge swivels around what's called a pintle or a pin. Here it is. It's a pintle, means little pin. It's about 3 feet high, I suppose, so it's not little, but it's bolted to the ground. And then the swiveling part of the bridge, this is that central section you saw, the box sections, that swivels round a cast bronze collar. Here it is. And that holds the thing central. But Brunel developed an idea, which he tried out here, which was to have a big nut, a bolt really, on the top, which screwed down onto some bronze thrust pads. And the idea is that you screw that down until it just picks up the load here. And the 4 wheels that I described, therefore, share the weight of the bridge with these pads. Now, we thought, well, we better take all this lot out. We'll unscrew the nut and or the bolt. I'm not sure what you should call it, really. I suppose a bolt. And just make sure these are all clean and in good condition. And then we'll lubricate them and put the bolt back in. So we got ourselves a very large spanner. This is the late Maggie Shapland. And you can see the size of this spanner, put on that bolt. And we've got a chain hoist. There's about 2 tons of pull there. And another 3 tons, I think that one is pulling there. We heated this with 2 oxypropane guns all the way around on this structure here. We, of course, soaked it in oil for several days. We pulled like anything. We hammered these round. We swore at it. Oh, no, I shouldn't say that, should I? but you can see we've tried pretty hard to get this to move round, and it did not move. So we tried again, and it did not move. We later discovered that others had tried it, and it didn't move for them either. And we think that what happened was when this was moved to the present location in 1873, they must have discovered that this was not going to move. It couldn't be adjusted. And we discovered later that they simply left out these pads. There is no metal in there. And so there is no way it could have been got out other than when they moved this bridge. So they didn't put those pads back in, probably because that component was seized up when they moved the bridge. In other words, it probably never worked ever since Brunel built it or had it built. And the reason is that this is a 10-inch diameter close fitting thread, and this is taken in the water and it's rusted up. There's no chance whatever of this ever moving. So whilst that might have been a good idea, Brunel's, I'm afraid it was what I'd call optimistic. And I think probably failed fairly early in the service life of the bridge. So this is looking up underneath. We raised the bridge about a foot, 300 mil or so in the center. Here is the bintle. There's that bronze collar I was telling you about. And because we couldn't expect to use that again, it's very badly worn, we put another bronze collar in further down. I just put that in to show that I don't just give webinars, I do actually do practical work as well. And that ring was inserted inside this plate. The whole lot was then slid down back into its original position. So we've created a separate bearing of the same sort of design, bronze against iron, as was there originally. So hopefully that will now serve as a centralizing arrangement to keep the bridge running correctly. And this is a diagram of the hydraulic jiggers that move the bridge. So this is the underside of that central turntable mechanism that you saw. The box sections go across here, and underneath is a track, and a wire, or originally it would have been a chain, comes out, goes round that pulley you saw in a previous photograph, and back, and is fixed. And that pulley is fixed to a hydraulic ram. You let pressure into the cylinder here, that pushes that ram out that way, pushes the pulley down, and stretches this, or rather pulls this rope. So that will move it in the anti-clockwise direction, and you have another one here to pull it in the other direction. And there it is. If you take up the steel gratings, which you'll see there, you'll find they're still underneath there, and we thought, well, we better investigate those to see whether they can be put back into working condition. Again, they were provided by the Armstrong Whitworth Company. Remember Ashton Avenue Bridge? Well, the same company from Newcastle on Tyne provided this set a little bit later. This is 1901. And the power from under full yard, 750 psi, applied to those rams will push out, or rather pull, I suppose, about 6 tons. So there's quite serious loads here. So we took out one set of these hydraulic jiggers, sent them away and had them tested and looked at. I'm afraid they're not in very good condition. They're in a pit, as you can see here, and in cold weather, of course, the coldest place is down in the pit. And so these things have frozen. Can you see there's a sort of seam along there? Now that is a repair. We didn't know that when we started, but it's cracked right the way along there and been welded up. Also, the rams here have rusted rather. These need to be machined clean. And if we were to do that, we would have to take so much metal off. We decided that was rather too intrusive. I don't know whether you can see a pipe running along here. That is a gas pipe, and it has little holes in it. And on a very cold night, they would turn on the gas, light these little lights, and the flares would keep this warm so that it didn't freeze. I hate to think what would happen if a series of these blew out and the pit filled up with gas, particularly if the other flares were on. I think it could have been quite exciting, but I don't know of any accidents. I'd love to hear about them if anyone has come across any reports of strange explosions in the entrance lock area of Bristol Harbour. So if we can't use those hydraulic rams, how could they be rotated? Well, we let a contract to some specialists. We had long discussions, and they confirmed that one of the ways of doing this, and there are several, one of the ways is to simply drive it round with an electro-hydraulic system. There's a motor driving around underneath. There are all sorts of problems with this to do with loadings and so on, but I won't get into the mechanical engineering. So it's likely to either eventually be driven by something like this or winched around with cables. It could be refurbished in situ. Now, I mentioned those 4 wheels. Here they are, and they shouldn't be flanged like that. These are not railway wheels. They should have parallel flat faces, cylindrical faces. This is where, because that central bearing wore, the bridge pulled sideways. If you remember that 6 tons, well, that's pulling the bridge sideways. That wore that central pintle very badly. So the track on the underside of the deck was scuffing round on these wheels and just wearing themselves away, wearing the wheels away. So that was quite serious. All the wheels were quite badly worn. 3 of them we were able to just skim back. But I just want to show you what these wheels sit on. Can you see there's a bearing here, and there's another one, of course, on the other side. And you may notice that this is another Brunellism. Those bearings are not cylindrical, they're double conical. This is what they run in. This is a piece of bronze. And you can see that it's conical facing conical. Okay, now that is not a great idea. It's quite complicated to machine these things. It's even more complicated to machine the hollow shape in which these journals fit in the bronzes. When you bring them to site and put them in opposite sides, you've got to get them thoroughly well aligned. Whereas if you can imagine, if this was cylindrical, it makes the alignment so much easier. You don't have to have them spaced correctly, because they will take up a position, provided there's enough space for the wheel to get in. You don't have to align them as accurately as you do with the double cones. So again, why did he do it? Probably because these need to be resisted, need to have force, axial force resisted. So the thrust face is, if you like, a cone. Now, if you have a parallel bearing, that's not a problem because you have a thrust face here, and that simply rubs around the face of the bronze. I hope I'm not getting too technical here, but you can see what I'm saying. If these were made cylindrical, which is so much easier to do, to machine and to set up on site, the bearing, the wheel, when it moves sideways, would bear against the side of this block. And that's what everybody else in the world did. You know, I've never seen these double conical bearings other than in this situation. And again, it seems to be another of Brunel's ingenious ideas, which in theory are good on paper, but in practice they're a pain to make. They're difficult to set up, and of course expensive. But nevertheless, it's still there, and of course we've retained it, absolutely. That was one of the bearings. You can just see the double cone, but the water's got in and rusted that. And so we had to put in a new shaft. Here it is. And we've put in some new bearings, beautifully made, cast and machined here in Bristol. And you can see that the wheel has been skimmed flat, or cylindrical, I should say. And here is the new one that's been made in Borough Foundry in Dudley. So this is a wooden pattern. The foundry are going to cast that in iron. There it is. And they've now put it up in that great big machine at the back to machine the wheel and the super bearings that go in there. Exactly the same shape as we found. And of course, the original is absolutely going to be retained. It's actually still on the site, and that will become part of the display. An original, but it unfortunately, this rim had worn so thin because of the scuffing that it was liable to collapse. So it's been retired, honourably, and a new made of the right size. Setting it all up was quite a complicated business. We had to make these special calipers which clip into the ends to set up the bearings. This is the sort of work we have to do to free up the nuts. So this volunteer is heating up the nuts, as you can see, that hold this down, and then we can use a giant spanner to free them up. This is one of our lads undoing the nuts underneath the tail bearings. So this is the cast iron weight I was telling you about at the back end of the bridge. And he's not laying underneath that, don't worry, but he's using a giant spanner to undo the nuts. Just to show you, this has all been done by volunteers, I should say, at weekends. So if you have a casting weighing 300 kilograms, how do you get it there? Well, the answer is in the back of the car. And then you create a luffing arrangement here, sort of derrick, and you roll it out of the car, up onto the bridge, and then along a little trolley like this. There it goes, and then it's craned in using another scaffold arrangement into its final position. It sounds easy, and actually it is. As long as you've got the right equipment and you're well organized, you don't have too many people, you have one person in charge, it works very nicely. Now, we're looking here, bottom left, at that primary structure. Do you remember the box section with the holes in it? Well, on the underside of that is a ring. There it is. It's a wonderful forging in iron. It's about 14 feet, I think it is, just a bit less perhaps, in diameter. But the water, of course, has been running down here and dripping off the underside. And it was very, very, very rusty, very pitted. But of course, it is on that track that the wheel runs. So there is the track, and there is the wheel. So we had to put a plate all the way round on it. Here is the plate being made, and that was then brought onto site in two halves, welded together. Here's the weld, which was then dressed off. This is a very strong, got to be a very strong structural element. So that's a crack detecting test here. We've done a test to see if there are any cracks, and you can see there's nothing there, there's no problem. So that was then installed and welded in place with these little skew members here to allow this to just squeeze up to the underside here. So there's an aluminium gasket in there and some gunge, that's a technical term, to stop the water getting in. So to allow that to squeeze up, we had this arrangement here. And that will ensure that not only is there good bedding all the way around, but the water can't get in. We don't want water to get in the future and start the rust again. Sorry if that all sounds a bit technical. A number of other trials were done as well. This is called hot set riveting. So we've put in a plate here, welded it round where there was a hole previously. This is to prove that a steel plate could be bent and fitted and welded to original wrought iron. And then we've remade these welds, these rivets, by putting in white hot rivets, which are riveted down from above and from below. So somebody has to lay down underneath the bridge and hold up the white hot rivet as the riveter uses a piece of pneumatic equipment here to hammer down the head. It's very noisy, but you can see this is the final job. Very, very neat. This is a new piece of plate on the underside, a new piece going up on up here as well. So this is to prove, firstly, the weld can be done between the steel and the wrought iron. Secondly, that the rivets can be put in this sort of location underneath the bridge in situ. And thirdly, that a sound job with good alignment and so on can be done. Also, of course, it was useful to know how long all this took, so that eventually a tenderer will be able to use our data to calculate how much time he needs to allow for doing each of these operations. We also did some glass cleaning and tried different sorts of paint. So we've got a lot of data, and we now have a full, credible plan of restoration, which has been costed at something in excess of £1 million to restore the entire bridge in situ. So I suppose I ought to appeal for £1 million. So if you'd like to just send me a check, no problem. We can have the bridge restored for you in about a year. Now we've been working towards trying to get this bridge to move, partly because we needed to know how much torque is necessary to make this structure turn. You can't finish the design of the drive mechanism until you know whether it's got to be 1 horsepower, 100 horsepower, or 1,000 horsepower. And so we engaged a strong lad and a girl and set up a chain hoist and gave it a jolly good pull after having done all that remedial work I was telling you about under the central support mechanism. And sure enough, it moved. Now, we aren't, of course, allowed to turn a derelict structure across a working entrance lock. So it only moved a short distance, but we satisfied ourselves that it would move in both directions. And that was very satisfactory. So we now claim that we have the only part of Brunel that still moves. Hope that's not a joke in bad taste. What else have we been doing? Well, a structure like this doesn't look great. It's rusty. It did have trees growing through it. It has graffiti on the outside, and it's half hidden under another bridge. If we don't raise its profile, tell people about it, and get people excited about its history and its potential, it will eventually just disappear from view. I don't just mean it'll rust away, it'll be scrapped. It nearly was once. And despite it being listed, things like this can be delisted and they can be disappeared. So we've done as much as we can. We've invited people round on all the open days, doors open days that we can. We've had a conference by the Institution of Structural Engineers for the birthday, 170th anniversary. We've had numerous interviews on the media. We've been in the Evening Post and so on. We've lectured to the ICE and to universities. We entertained Mayor George Ferguson, who was very supportive and said, absolutely wonderful. I'll support you however I can, but no, don't ask me for any money. And we're trying to get increased social media coverage, which we haven't done successfully so far yet. I mentioned the 170th anniversary. It was a great thing in September 2019. We even had Brunel come back and just check the bridge out. Monthly volunteer work days until we got locked down. This is the redoubtable late Maggie Shapland, who was in there doing everything that nobody else wanted to do, right down in the bowels of the structure, and had a little arrangement for digging out all the stuff that got down underneath the wheels. You know, Maggie would go in and do what everybody else thought either wasn't possible or somebody didn't want to do, and didn't mind climbing underneath and so forth. We've done a lot of other work around trying to maintain the shed and painting out the graffiti and so forth. But you can see the dedication of these people. Oh, this man is needle gunning the underside of that ring I was telling you about. So we're looking up underneath the turntable, as we called it, under the bridge. You can just see a wheel there. We've lifted the bridge up about 300 mil, and he's laying underneath, cleaning all this off. It will then be painted with several coats of paint, and then that ring I showed you will be squeezed up underneath and then tack welded on. We've tried to encourage kids. About 5 years ago, do you remember grommet spotting? Well, this lad was 11. His name was Charlie, and he went out with his father one afternoon, Saturday afternoon, to go grommet spotting. And he got as far as the bridge, and one of us was laying underneath the bridge, and he stopped and he sort of poked his head and he said, "What are you doing?" And he said, "Oh, well, we're trying to do a little bit of work on the bridge. Would you like a pair of overalls?" "Oh, can I, Dad?" And he's still working with us, actually. He's grown up now, but he has thoroughly enjoyed this work that he's done on the bridge. Here he is now. I think he's either 17 or 18. He's just moving on now to college. And he has grown up so much on this project and such capability that he now leads these projects. Can you see this is how we're lowering in that wheel I was telling you about? We had to do it 4 times, of course. And Charlie, after he'd done the first one, we supervised him, of course, but let him get on and do the installation of the others. This is Bailey. He was aged 8 when he started with us. And yes, we eventually got Charlie supervising Bailey, undoing those nuts and so forth. So this is real hands-on stuff. It's not as dangerous as it looks, don't worry. We haven't lost anybody yet, we don't plan to. But I think this is one of the really, really important things about this project. It's hands-on, it's engaging the kids, it's something they'll never do at school or probably nowhere else either. I hope it's engaging them in mechanical engineering and in heritage and history, and certainly Bristol's history. So this is, I must move on. I get terribly enthusiastic about this. Yep, we have another wonderful volunteer from the Bristol Film and Video Society. Can you turn the light on, please? We put monthly reports on our website. We're on Facebook and so on. So we're trying to do as much publicity as we can. Okay, I'm just cantering down towards the end now. I just want to sum up a little bit and say what the significance or the heritage value is of these wonderful things that I've shown you. This is how historic England define it: evidential value, historical value, aesthetic value, and communal value. Let's not go into that, but just, I think I can summarize this by saying that the Western Harbour assets provide evidence of commercial achievement. The investments and success of Bristol's investors, the venturers, the merchants, the ship owners, the captains, the traders, and of course of two South Bristol industries, the tobacco industry and Bedminster's once significant leather industry. For an engineer like me, and I think a lot of others, the evidence of technological change is really interesting too. The increasing size of ships requiring larger locks and better aligned with the river, developing technology from stone to concrete, manual to hydraulic power, wrought iron and cast iron to steel, riveting to joining by welding, and those plain bearings we saw with iron running in bronze later became roller bearings. And we have evidence of all that. And then, of course, the increasing road traffic requiring wider and stronger bridges. That's why we now have the Brunel Swivel Bridge underneath the Plimsoll Bridge. They had to use the same place because that's where the roads were approaching. And so we've got two stages of bridges there. And of course, the demise of rail traffic. That Ashton Avenue Bridge was a rail bridge. Then the technological innovation, Jessop's original lock design and Brunel's innovative design of his gates and lock, and the swivel bridge, Coignier's system, of course, and Thomas Ware's entrepreneurial achievements. And then the sense of place. It is the gateway to Bristol's shipping, which is going in and out of the floating harbour. It's emblematic of our trade with the empire and the influence that we had on world trade. This is important stuff. And it all focuses really around the entrance locks there, where the old route of the Avon and the New Cut and the floating harbour had to, of course, have all these major civil works to manage all that shipping and the land traffic that was integrated through the same area, whilst also controlling and dealing with the problems of floodwater and silt. It's a considerable civil and mechanical engineering problem dealing with all this in one place, and it's all there, and it goes through 200 years. Absolutely amazing. And most importantly, it's the first and last point of contact for Bristol seafarers with their city. Now just think about that. I'd love to develop that, but I just lay in bed tonight and think about that. The first time and the last time you see the city as you go round that corner into the Avon is at Cumberland Basin. And then it's a lung providing breathing space. It has mixed vistas, industrial, maritime, residential and countryside. Where else are you going to find that? There are not many places where you'll find that mix of industrial, maritime, residential and countryside. It's a recreational space with free access. I'll go on a long time about the diverse engineering structures and how they're so interesting, both visually and technologically, but I mustn't. And just the scale of it all, the superhuman scale of the waterways, the docks and the bridges, it's just big and impressive. And I mentioned a couple of copies of this bridge. Well, here's one. that dated, that's definitely an exact copy. It was constructed just 7 years after Brunel's Bridge, and it's still over the Petrovsky Canal at Kronstadt near St. Petersburg. Clearly a copy, and it's just been restored and it's still in use for road traffic. Absolutely amazing. Can I suggest that that swivel bridge in Bristol is as iconic as the SS Great Britain or Concorde? I don't think I'm overstating that. It's been copied both in Bristol and around the world, and it was a very, very early pioneering development by Brunel, and we should be proud of it. Well, I'm proud of it. I hope you are too now. Okay, just finally, let's have a quick look at the threats. Clearly, neglect causes decay in the different materials, damage from vegetation and silting. So it gets vandalized. We've got lots of graffiti there. The public lose interest in it, don't take any pride in it, don't use it as much as they would, perhaps if it looked a little bit better. And as I said at the outset, the danger is eventually it gets lost because it's just falls from view. Ignorance and inaction. I'm not trying to get anybody here, but our city, of course, owns this bridge, and it is the responsibility of officers who are, they're understaffed and they're overworked. A lot of interest has been coming from the amenity societies and the heritage groups and so forth, but that's been somewhat stalled during COVID. And I have to say, again, I don't want to be unkind here, but they mostly have aging membership, and one wonders what's going to happen in the future. Lack of statutory protection for the junction lock and its swing bridge, the north entrance lock, and the buildings and dock furniture around the entrance lock, and of course the tannery buildings at Thomas Ware. Redevelopment, let's not talk about the Western Harbour scheme at the moment, but I see that potentially as an opportunity, not only a threat. And I'll talk a little bit about moving the swivel bridge in a minute. And lack of human and financial resources. I'm afraid that's rather obvious and nothing much we can do about at the moment. The SS Great Britain have currently got into the National Heritage Lottery Fund an application for about £10 million, a part of which would be used to move the swivel bridge to Albion Dockyard here. This is the dockyard entrance, which has another caisson lock gate in it. And over there would be the swivel bridge. It would be sited here and swing across there, next to the Great Britain here. Now, there are advantages to this scheme in that if they get their grant funding, they will spend this money on restoring the bridge, which is great. And it won't be subject to flooding. Although, of course, there are discussions now about the new flood alleviation schemes in Bristol, which will eventually happen. Otherwise, we're all going to go underwater in the centre of the city. So there will be some alleviation schemes, but they're likely to be long term. There will be certainty over maintenance. The SS Great Britain is a very responsible body when it comes to conserving historic structure. Of course, there will be increased visibility and footfall, and they do have a fundable scheme. On the other side of the scales, the disadvantage is that the bridge will be taken out of its context. It was historically very much part of Brunel's and Howard's locks. The loss of a major heritage asset there could seriously affect the prospect of other assets in the area, because the evidence of the road crossing will be eradicated if the swivel bridge goes, and so there will be no reason to reinstate that low-level crossing if the bridge, and certainly its abutments, are lost. It would be very expensive and difficult and perhaps rather risky to the structure to move it and to construct new foundations and restore and re-erect it. The other thing that concerns some people is that at the moment it's free to come and have a look at the bridge and walk around it and so on, whereas if it's in a pay-to-view area, whilst it might be better maintained, it won't be free to visit. So finally, ladies and gentlemen, the reason I'm excited about this whole scheme is that by the scheme, I mean the eventual development of this end of the city harbour, that is Area 1, as I described it, is because I can see there's a lot of opportunities for improvement and refurbishment and better use. I do think we can improve the road system. Whether or not we should have a new bridge across here is something I'm not going to get into now, but let's not close our minds to it if there are benefits. New housing and leisure uses from the development, I do believe that is possible. Obviously not too many houses, but I think we want to develop that area moderately. And that will certainly improve the area, the appearance of the area. I would hope that as collateral benefit from all this development will be restored and interpreted historic features. As you can see, there is wonderful potential of all sorts of interesting historic features there. And a scheme like this will hopefully get those restored and interpreted to the public, leading to much better use and increased care of those assets. And why shouldn't this end of the harbour become a new destination to increase Bristol's offer both to our residents here in the city and to visitors? I think it has a huge potential. Just look at that view. Yes, I can see the mud, but the tide does come in, and that's part of the history anyway. We're looking down, of course, at the Clifton Suspension Bridge, but also the bridge, Bristol's bridge to the rest of the world. Bristol means the place of the bridge. Surely there's potential here. Look at that little area there on the right. The view from there is absolutely fantastic. Go and have a look at it sometime. Not right at the moment because it's roped off, but in about a month's time, hopefully. So how can you help, folks? Well, why not join the Bristol Civic Society? They're taking this whole issue of development seriously. You're very welcome, especially if you're young. I'm allowed to say that. This is your future. Come and join the Bristol Bridge Volunteer Day. The next one is on Saturday, May the 29th. We should be doing all sorts of interesting things. This guy, incidentally, is not painting graffiti, he's overpainting it. Why not arrange activities yourself? There's lots of work needs doing, maintenance and litter picking and all that sort of stuff. We need to do more study on this area, to survey it, to record it, assess its significance and so forth. If you'd like to contact me, just jot that down quickly. If you'd like to put my email address down, jandgwallace@gmail.com. I'll guide you in the right direction or incorporate you into one of our work days. So finally, just to show you that this is a live issue, this month Bristol City have issued invited architects to tender for a place-shaping vision to be prepared for the Western Harbour. So let's get involved now in it, folks. Now is the right time. Thank you. Sorry, I've slightly overrun.
Wow, well, thanks very much, Jeff. Can you stop screen share and we can see people? Brilliant. Well, thank you very much I thought it was a very great presentation. Judging by the comments on the chat, lots of people have really enjoyed that. I think you've done very well to get quite a lot of young people working on your bridge. I don't know what you're moaning about on that. But you're right at the end. I mean, I do think the Western Harbour, whatever it's going to be, is both an opportunity and a threat, and there are lots of opportunities in there. One question I have, which has come up on the chat, is why the listing and protection of assets in the Western Harbour is so, it seems quite random, because lots of the things you showed us this evening aren't actually protected, are they?
Well, I need to be careful what I'm saying here, Simon. I don't know the answer, but what I've been told is that operational assets like the Cumberland Basin, the entrance lock and the junction lock, and the junction lock bridge and other operational assets are not listed because they would then require listed building consent to do any maintenance or major work to them. And I assume the council would be giving themselves consent. So I think there is some sort of planning agreement, I think, probably for them not to be listed. But it seems to me this is something we ought to be finding out about. I'm afraid I'm rather new to this. And I don't know the answer to your question, but I think we ought to be just looking into it. I'm sure the council will be acting very responsibly, but I think it does need, to have the balance and checks of the listed system. There probably is a system, but I'm afraid I don't know what it is.
The other thing that would be great if you could get those sluices to work and clear that mud out.
Yeah,
we could actually see where that boat was resting on the grill. That would be amazing.
Yes, that actually was in Jessop's Lock, that area, and there is no water flushing. There isn't a facility for flushing water through there. Right. So it would have to be washed out artificially, or possibly create some sort of channel through. If there may have to be major works done there anyway because of the flood defence system, alleviation scheme. In which case, that needs to be borne in mind.
I'm just looking through the chat. I can't see any. There aren't so many questions. A lot of people saying they've really enjoyed your talk this evening. We did arrange a trip to the tannery, as Mike said, last year, but we had to stop that because of lockdown. It's a place I've always wanted to go to. It looked absolutely amazing on your pictures, I must say. What else have we got on here? There's other stuff about recording the information. And of course, we don't really know what Western Harbour is going to be in terms of development. We have this consultancy study, which I hope everybody will have an opportunity to get involved in, because we do need to make sure that we influence what's going on and be part of it. So we'll be certainly watching out for that.
Very much so.
No, I can't see any other questions. Everybody just saying really interesting and informative.
Jeffrey Smith has tried to speak.
Hi. Can I read my question out, which is in the chat?
Is it? Of course you can, Jeffrey.
Are there as-built civil engineers' drawings of lock and other harbour walls and structures? Are they stone gravity retaining walls or possibly concrete? How thick are they at the bottom? Can other structures be built on them, bearing in mind all the hydraulic ducting and sluices, etc.? I'm thinking of future development there. I have to admit I'm a civil engineer, Jeff, so I'm looking at it from that angle.
That's a very technical question.
Yeah. Well,
the main thing is, are there as-built drawings original? Because one doesn't know how thick the lock walls are without. It's very difficult to find out otherwise.
Yeah, I think there are drawings, but I don't know what they are or where they are. So I'd know where to look. I would start with the city archives, but I'm afraid I don't know. I haven't researched that area. That's one of the things I was asking for. If we could have volunteers to start probing into all of this information, I think the Civic Society is a good group to assemble all this information, to motivate people to actually go and sniff into all these archives and fish out the information. And now is the right time to do it. There's quite a lot of interest, a lot of excitement, and I think we had 120 participants today. So if we can't find 3 or 4 volunteers, I'd be saddened.
Slight problem with that, Jeff, is the archives are actually shut still at the moment.
I'm sure it all opens next month.
Yeah, I think so.
A lot of it's online, I think, anyway.
Yeah, quite a lot is. There was talk, wasn't there, of Historic England actually doing a specific survey of Western Harbour in terms of the industrial heritage and other heritage, but I never knew what actually happened to that, whether it actually got commissioned or not. I don't know whether you've heard anything about that, Jeff. Good. I mean, I think we've gone on long enough this evening. The questions coming through are really saying that we need to be careful not to lose this industrial heritage as development proposals, whether they're flood defences, roads, or actual buildings, because there's a whole host of change actually happening. Ted, do you want to ask a question? I've got one on here. Where are you? Are you going to ask it?
Here I am.
There you are, Ted.
Can you hear me?
Yep.
Yeah, I'm not very good with the chat thing, and my typing is dreadful. Okay, so there's 2 questions really. One is a simple one. Loads of information in your talk, Jeff. It was just brilliant. It's some of it, at least, that I can kind of buy in a pamphlet or something like that. Is there a simple guide that I could use when I'm walking around with visitors or whatever that might be helpful?
A guide to what? Sorry.
A guide to the engineering work that, in particular, that you know
No. No, I don't think there is, and we should probably we ought to be producing one. No, I don't think there is. That's partly why my main interest really has been initially in the swivel bridge, and I've been asking these questions myself, and so I've got drawn into having a look at all the other places, the other places around, only to discover, as you're saying, there isn't very much written documentary information.
No,
I think we're finding out where it might be. We just need intelligent people to go and sniff it out and to write it all down.
Yeah, okay. So that's a great idea, and I think that might be something that people might want to follow up on, because it's really it's a very rich vein that you've opened up. The other bit, which is kind of more about the Western Harbour and future development, is I'm aware that the new cut is in poor condition, and that is also, it's kind of like I suppose it's like the rectum of the whole floating harbour thing. It's a bit that we don't talk about, but actually makes it work. Yeah. And to be frank, you know, there's a lot of effort has gone into it. There's a brilliant plan, and there's some history in it, and some people's history, as well as engineering, as well as the bridge you pointed out. And I just wondered if there's any. I couldn't see much reference to it in the vision document that Simon sent me from the City Council for their commissioning at the moment. I just wondered if anybody in the civic society's thought about, is there any heritage potential in bringing the new cut into, and placemaking potential into the whole picture, because it's just not touched on at the moment, as far as I can see. It's just seen as a repair problem.
The new cut is in that area 1 of the of the conservation area, which is what I think is what's being focused on now. I'm not sure whether that's coincidence, but certainly it is that area that's being focused on.
No, I see it's in the map, but I can't see any reference to much. You know, I just wondering if anybody's taking an interest, because mostly people talk about the chocolate path being broken down and things like that. So it's all kind of negatives rather than its potential. That's really, I'm just throwing that open.
Yeah, well, that's sorry. I think that you brought up a really good point there, Ted. What we're doing at the moment, of course, inevitably in times of stringency, is firefighting. So when the wall of the new cut falls down, we have to find £1 million and a bit to repair it again. And the next bit of the wall will fall down next. And then we have another. What we need is something much more comprehensive. And that, of course, is what Mayor Marvin was trying to do with the Western Harbour. He was trying to have a look at the whole thing in a much more global way and saying, if we can find X billions of pounds, we can then start doing some of these things. We can do the whole lot. But of course, that was a very ambitious thing, starting with the funding, understandably, and then no doubt would go on to work out how to spend it. Now, I think people should go the way around, so that let's try and do this, and this. Now we're going to see if we can find the funding. I'm not a politician, so I can't say which I think is most likely to work. But
I've got a technical question for you here, Jeff. There's a technical question on the chat. How closely related are the Saltash Railway Bridge and Brunel's other bridge? Or are they closely related at all?
No. The Saltash Bridge, of course, was built right at the end of his life and was developed from all sorts of other ideas that he had. They're not really the same sort of thing. The Saltash Bridge is a sort of self braced bridge, so that has a tube which is constructed in the same way as the Brunel swivel bridge, but it's not otherwise similar. It's not the same function. It has a strut, if you like, and then a suspension bridge built in it as well. So it's a very different concept, but built of the same materials using the same techniques.
Right. I think we've probably had enough there, Jeff. I mean, I'd like to thank you very much for the wonderful presentation this evening. I think we've all learnt a lot. Personally, I'm a bit daunted by trying to investigate even more on this subject, but we'll talk outside the meeting, Jeff. So thank you all very much. We can't give you a round of applause on Zoom, but assume there is one, because I know everybody's really enjoyed it this evening. And I'll certainly be in touch with you about Western Harbour and how we might work together in the future. So thank you all very much this evening, and good night.